So here's the next big topic called voltaic cells. Sometimes we're called galvanic cells, but they mean the same thing. So when you have voltaic cells, there's certain terminology that you need to get. So the whole purpose of a voltaic cell is to use nature's desire to move electrons to generate electricity. Okay? Now, we'll talk about this. We're going to show. I'll go back. I'll show you what one looks like in just a second. But these are not going to solve the energy crisis of the world. Okay? You can generate some electricity. It's basically how all batteries work. All batteries work by one simple idea, is that you push the chihuahuas up a hill. They store potential energy. What the batteries do is allow the chihuahuas to roll down the hill. Okay? That's it. That's how all batteries work, is that they store potential energy of the chihuahua. So, like when you start your car, you have built-up chihuahuas. You start the car, the chihuahuas flow through the starter, they make the starter spin, your car starts. At night, what do you do with your phones?
I charge it.
What do you do?
I put it in the plug-in.
You plug it in. What does the electricity from the wall do?
It goes in the phone.
It pushes the chihuahuas up the hill.
But it stops at 80% because they're like, oh, save power.
Oh, I know what you're talking
You know,
about.
But no, it'll generally kick back in like around 4 or 5 o'clock.
This is also true.
Yeah, that's true.
Okay. So then as you go through the day, what are the chihuahuas doing?
They're leaving.
They're not leaving.
They're falling back down, but really
They're rolling down the hill. But as they roll down the hill, they do work. Okay? Now, for those of you that haven't had physics, which is a small minority of you, but when you talk about physics in terms of work, you're talking about a force being exerted through a distance. So when the chihuahuas move, they do work. They have you can watch annoying, stupid TikTok videos. Okay? They are. Don't lie. Okay? Or you can send Snapchats or whatever. Okay? With the funny little faces. Okay? And all that's doing is the chihuahuas are stored, they move downhill, the chihuahuas do work, and at night you need to push the chihuahuas back up the hill. Okay?
So over time, the battery, like gets bad. Is that just overused?
The hill gets smaller.
The hill gets smaller.
It's based on the
Well, it's basically how batteries typically degrade. It builds up what they call dendrites, and the dendrites build up on the surface, and that inhibits the ability of chihuahuas to stay up the hill.
Mr. Bergkamp, what's the word above bridge?
Salt, right?
Salt ridge. Yeah. Okay. Now, so here's what we're going to do, and this is what I have built in the back. So I'm going to have an elemental strip of copper in a solution of copper nitrate. I'm going to have an elemental piece of zinc in a solution of zinc nitrate. Okay? I'm going to have it hooked up to what we call a voltmeter. What the voltmeter does is, oddly enough, it measures voltage. Okay? Shocking as that may be. So volts, remember, are joules per coulomb. Okay? So you can look at this in terms of it's the amount of energy per charge on a chihuahua. Okay? So the more voltage that it is, there's more energy per unit of charge on the chihuahua. Okay? This isn't per chihuahua, it's the charge on the chihuahua. Okay? So neutral chihuahuas don't count, okay, like the sheepdogs. They don't have a charge. Okay? And we're not going to make the St. Bernards move because they're locked up in the nucleus. So the only thing we can do is make the chihuahuas move. So all electricity is generated by the movement of chihuahuas, okay? Because they're the only ones that can move. So if something is a good conductor of electricity, that just means that it allows its chihuahuas to move. Copper, great conductor of electricity, okay? The chihuahuas move, okay? Plastic, not a good conductor of electricity. The chihuahuas are pretty much locked in place. That's the difference. Okay. So here's what I want somebody to do. So find me the reduction potential for Cu2 plus gaining 2 electrons and turning into elemental copper. So what's that reduction potential?
0.34.
What was it?
0.34.
0.34 volts, right? Where's, relatively speaking, where's that at on the periodic table?
About
Top, bottom,
75% up.
up. It's on the upside, right? So do you think this really, really wants to happen? Yeah, okay, it's fairly high up there. And again, why do you think we use copper in jewelry or as an ornamental metal on the outside of buildings? Yeah, it stays in its elemental form. It really doesn't react, okay? Someone comes up to you and says, hey, buddy, I'll sell you a roof of sodium metal. Probably not a good idea to buy it. Okay, number one, it's soft. Number two, it's going to float if it rains. Number three, it's going to react violently with the raindrops, and your house is going to catch fire. So if someone says, hey, let's put on a sodium roof, don't. Not going to end well. Now, let's talk about zinc. So find me Zn2 plus 2 electrons turning into elemental zinc.
Negative 0.76.
Negative 0.76 volts. Does zinc really want to gain electrons? No. It wants to lose them. So, if you just had this, copper and zinc, okay? Which one is going to be reduced? Now listen very carefully. You have this potential reaction between copper and zinc. What is going to be reduced? Listen very carefully. There's 4 options. The copper ions, the elemental copper, the zinc ions, or the elemental zinc.
Copper ion.
Why?
Because on the blue sheet it's above and it's on the left
Yeah.
side.
Look at the chart, right? This really wants to go in this direction. So the copper ions really want to take in electrons. Okay? Okay? So in terms of like a party, the copper ions are going to be going, yo, chihuahuas, come this way, okay? I got good treats, okay? Come on, let's party. We'll bring on the chihuahuas. Now, what is going to be oxidized? The elemental zinc or the zinc ions? What's going to be oxidized? Zinc or zinc ions?
Zinc.
Why zinc? Why not zinc ions? Yeah, it's not going to go down. You never see Zn3 plus. Okay? Different mother. As all 18 years can attest. Wow. She's older than you. Oh, never in my life. Okay?
Never in your life have you seen it.
Never in your.
I've never seen it in my life either.
There we go.
There we go. That says a lot. So, you have zinc. Now, does zinc want to lose electrons? Absolutely.
Yes.
So, the copper ions are going to be,
Reduced.
so these are going to be reduced. The zinc is going to be oxidized. Oh, so we're going to have a redox reaction. All right, Louise. Okay. Now, look at this situation. We have copper nitrate, and we have a strip of copper, and we have zinc, elemental zinc, and we have a solution of zinc nitrate. Okay? So, the copper ions here, what are they going to do?
Which one?
What are the copper ions in this solution?
Electrons.
They're going to gain electrons. Okay? They're going to gain electrons. And they're going to turn into what?
Copper.
Copper. So in this cell, I'm going to make more copper. Okay? So what's happening in the copper cell? Oxidation or reduction?
Reduction.
Reduction. Okay, so this is going to be the reduction cell. Now, what's going to happen over here on the zinc side?
Zinc's gonna get, the zinc element is gonna get.
Oh, the elemental zinc is going to turn into, so what's going to happen to the amount of zinc?
It decreases.
I'm going to decrease the amount of zinc, but what's going to happen to the concentration of the zinc ions? So I'm going to increase the concentration of my zinc ions. Now, over here, what's going to happen to the concentration of the copper ions? Copper ions is going to go down. So here's basically what happens if you want to apply this to a social construct. Okay? So basically, the copper ions are over here, and they're sending a text message or a snap or some form of social media over here to the chihuahuas. And they're going, hey, come on, man, this is going to be good. Okay, we got some good treats, we got the swimming pool, right? Come on over, right? And the chihuahuas, again, have to make a decision. Do they stick with the zinc that they've been together a long time? Okay? Or do these chihuahuas bounce and come over here with the copper? That's the fundamental decision that we have to make. They bounce. Okay, they go, love to stay in chat, gotta go. But here's what happens. The zinc atoms, they get pissed. Because the other zinc atoms go, dude, you bailed on the chihuahuas. They left you. Now, the rule is, once the zinc gives up the electrons, the other zinc atoms go, you're out. You gave up your electrons. So then, you have to go into the solution. No, but the copper ions are just the opposite. The copper ions go, they're like in the club. Hey, the copper ions go, gain 2 electrons. Cool. Now, we can turn into elemental copper. Okay? Got the idea. Okay, so stop you on the camera. Bring back